Hello everyone and welcome back to another episode of the Hidden Quantum Champions. Today we again have a very big one, a big name in the industry. So get yourself something to drink and then let's jump right into it. Let's get ready with it. Today we are talking about D-Wave. So D-Wave is another one of those very well-known companies in the quantum technology space. They are an, let's say, provider for quantum annealing systems. So these can be used to kind of calculate very specific optimization problems. We will learn more about that in a second. Also important to mention, they are one of the players that are like purely quantum and stock listed. So another one of these stocks that are being discussed quite a bit in the media, where it might really sense to kind of learn about what the company is doing, how the technology is working, and then making informed decisions. That's it. This is not like an investor's advice video here. It's just for you to learn about the company, what they do, and how the stuff is working. So what do we see here on the website? So there are like different tabs up here. We will look at them in a second. But first of all, let's look at the starting page and go through it. So on the right side, we see what is actually, let's say, the heart of your system. So here in the center, I guess we see the chip, which is going to be the superconducting technology that is being used to do this quantum optimization. Then we see a lot of cables evolving around this here with these connectors up here. And then you see that is connected to a type of chandelier-like structure that we've seen before. That's because it goes into a super low temperature setup, like in a dilution refrigeration cryostat. Now let's see what it says next to it. So we see here Advantage2 system, our most advanced and performant quantum computer. We are pleased to announce that the Advantage2 system is now generally available via the Leap Quantum Cloud Service and for on-premises installation. This annealing quantum computer is a powerful and energy-efficient system capable of solving computationally complex problems in business and science. So you see they are in the compute space. They call it here a annealing quantum computer. So this is kind of to point out that like it is doing compute tasks, but it is a little bit different from what we see in this other computing space, where they're talking like about gate-based quantum computers or general quantum computers. These general quantum computers, they operate on specific gates that are like called quantum gates, and they can do specific operations. This one here is using a technology called annealing, and that can be used to encode a very specific type of problems. And we will, I guess, learn here in this sectors tab later on which type of problems this can be actually applied to. So what do we see here? I guess these are some news here. So new study, surveyed business leaders expect significant return on invest from quantum optimization beyond classical, first to demonstrate quantum supremacy on useful real-world problem. So that's a big statement, a big claim here that somebody is saying they have demonstrated quantum supremacy on a useful real-world problem. And I guess we will learn more about that in a second. And then we also have here the LEAP Quantum Launchpad program. Quantum Realized, D-Wave has developed a clear framework that deflates the hype, helping you develop an informed position on quantum. The framework consists of 3 simple benchmarks to consider when assessing a particular quantum company's value. And then we see here powerful commercial and trusted quantum solutions. So optimization systems, cloud service, developer tools, research, professional services, training, and quantum AI. And then there's a little video here which starts with the chip itself. So here we can see the actual silicon chip. So I guess, yes, it's actually silicon technology. And on top of that goes metal, like little metal rings that become superconductive at these super low temperatures. And these superconductors, they form states that can then be used kind of to encode quantum information. And if you want to learn a little bit more about that, I will link you a video below in the description, which is a recording of a live session that I've been hosting earlier this year, talking a little bit about what D-Wave has just recently published at the annual Qubits 25 conference. So if you're interested, check out the video description for more about that. And by the way, if you like to have another live session, please also let me know down in the comments below, then we will host another one later this year. Okay, some customer success stories here. So complex problems, useful solutions. Patterson Food Group expends 80% less time and effort on creating complex employee schedules. Then we see here Ford Otosan builds production schedules 83 times faster. And we also have NTT Docomo improved network performance by 15%. Then we have some latest news also here. There's a new study, more than 1/4 of surveyed. Yeah, that's something that we've seen before, and other press releases as well. So let's hop back up here and take a look at the products. So again, as we've seen also with other players in the quantum computational space, there is a cloud platform, which is part of this Leap Quantum Cloud Service, where you can access the computer via some cloud interface. Then we have the product overview, which I guess is like the different platforms that they have, and the professional services that evolve around this, which usually include something like a consulting service, where people actually help you identify problems in your business that can be interesting for quantum solutions. There's more about the systems, learning solutions, which is also, of course, to the near and dear of my heart, like educating people about the quantum technology. And then there's also software and tools, because it's not enough to just provide the hardware, right? You also need to have a software layer on top to actually manipulate the states, create algorithms, and then also execute them, right? So quickly hopping on the cloud side of things, here the cloud is called Leap, the real-time quantum cloud service built for businesses. I think, if I understood correctly in the Qubits 25 conference, this is also something which is being used in production already. So there are like companies who are running algorithms in their production on these machines. So there's like a very high uptime requirement, of course, because if you, use it for your production line, you don't want this to go down, right? So that's like a very advanced system, I think, already. So you see here immediate access to the latest and greatest quantum technology. So you don't have to buy it and wait for it to be installed, but like you get the latest system already. Here it says the Advantage 2 prototypes made available prior to full product launches. So that's like even before you get the earliest access that you can get to one of the systems, like the latest system is, I guess, via cloud. Then you see the fastest path to quantum computing, no PhD required. That's bad for me, because I spent a lot of time doing that PhD, and now people don't even need it to get stuff up and running. So you see here, getting started with Leap Service doesn't require a quantum physics degree. And I think that refers also to the tutorials that they have, where they explain the concept, where they explain how to use it, right? You see there's 2 million variables, 100 seconds for practical applications and real-time answers from the systems, I guess. Build, test, and deploy more easily with less wait time. Comprehensive, useful, practical, top-tier compliance. So you also see here the Leap Services SOC 2, Type 2 compliance. So that's like very much into productizing those services in the existing IT space, right? Practical quantum computing for real world in production applications today. So that's like also again targeting people that really want to move that stuff already into production. Get started easily, ramp up quickly. So there's like documentation code example and the D-Wave GitHub repository, where I guess they also publish some of the stuff that they are doing, solving complex problems with quantum computers. Jumpstart your journey. There's this Launchpad program as part of the Leap Quantum service. And there's also some email marketing list here. Let's hop on to the next one, which is the product overview. So powerful integrated end-to-end quantum platform, hardware and software better together, the entire ecosystem from hardware, pre- and post-processing software, open source tools, and hybrid solvers is designed for performance. With the advantage2 quantum computer and Leap hybrid solvers, businesses can run larger, more complex problems and get better solutions across broader problem classes. A path to gate, model, and cross-platform quantum access. Just like with quantum annealing, our gate model program is focused on the vision of delivering a working technology at scale that will bring value to industrial customers. Our nearly 20 years of experience in pioneering superconducting quantum annealing systems is a backbone for our ability to build scalable gate model quantum computing technology in a multi-layer fabrication stack. So that's also a very interesting point here. I talked before about this annealing related technology. So that's like where D-Wave actually started. And now you see that like with these announcements here, they are moving also towards this gate-based approach that like all the quantum computing companies, or a lot of quantum computing companies that we've looked into before, are also kind of going into. And yeah, they also say here that like, okay, they've been working with superconducting technology before, so they kind of know how to do that. They have probably gotten their processes already straight. They know how to fabricate these chips in a reliable way and how to integrate them and how to also create the whole system around it. And now they basically move existing stuff towards this new approach, which they, I guess, say here more or less directly gives them a competitive advantage. Then again, we have the Leap Cloud First and Enterprise Scale here. And the advantage2, quantum computers built for businesses. So the advantage2 is the most powerful and connected quantum computer in the world, featuring 20-way qubit connections and a new processor architecture with 4,400 plus qubits. So you have these 4,400 plus qubits. You have 2 million variables. Variables, I guess, mean like when you encode a specific problem, then yeah, okay, you can input certain variables, and there's also, of course, there's not an unlimited amount. If you have a limited amount of hardware, you cannot put an unlimited amount of variables, and the variables can be like, I don't know, the conditions that your problem has to operate in. Like, I don't know, you want to solve the traveling salesman problem. You can only the traveling salesman problem is a problem where you basically look at the shortest connection between different cities. So you have a traveling salesman who wants to visit various different types of cities, and you come up with a path which connects all of them at the minimum distance, for example. If you have only a very limited amount of qubits, you can of course not put an endless number of cities in there, because you somehow have to get the information about the problem, like the location of the different cities and the path distances between those. You have to somehow get that onto your computer, right? And that's kind of the idea here, I guess, that like with 2 million variables, you can encode pretty complex problems, but maybe not all of the problems that you have. But I think with 2 million, you can already do quite a bit. So like 5 cities should easily work on that, right? So then here also it says 100, I guess, seconds, hundreds of applications across domains like manufacturing, logistics, retail, and life sciences already exist using D-Wave quantum systems today. And then we see here Ocean, modern quantum application development tools. The Ocean tools are a suite of open source Python tools accessible via Ocean Software Development Kit on both the D-Wave GitHub repository and within the Leap Quantum Cloud Service. The Ocean tools empower developers to experiment, rapidly develop, and harness the power of the advantage2 quantum computer to solve complex problems. So we see it's like a Python-based toolset that is open source. You can see it on the GitHub repository, and it's also available in the cloud. If you want me to do like a little exploration series on that, let me know down in the comments below. I'm happy to actually hop on the platform that D-Wave has and actually do a little bit of a coding session, either maybe in a live stream with you or also record it as a video tutorial. just let me know down in the comments below. D-Wave launch, world-class quantum professional services. So there's like the D-Wave launch program helps business get started on their quantum journey, aimed at guiding enterprises from problem discovery through in-production application development. The launch program takes a multi-phase and high-touch approach to support customers' business success. So this is again like this consulting service that helps you to identify problems and then move them towards the specific hardware that in this case D-Wave is providing. And then the final one here, see our products in action. D-Wave users have developed more than 250 quantum applications across a diverse set of industries. Discover what users have built with D-Wave quantum technology. And then you can learn more here about the use cases. But I guess we will see that later on here in the sectors as well. Let's quickly check on the professional part. Yeah, you see here the problem solving, quantum proof of concept, product pilot, and then also in production guidance, because yeah, as said before, they can even move you with these compliance solutions into something that you can use in your production. You see the different stages here. Okay. Then we also have the different systems here. So the Advantage 2 is the latest system, the most advanced and performant quantum computer. There's some announcements here and videos. There's an explanation here. You see the cryostat system in here with the vacuum tubes and the cooling solutions. You see that there's like quantum control electronics to actually create those signals and actually measure these signals. So it's very close here to the cryostat where actually the electronics is being hosted inside. You see there's a cryogenic cooling system here that includes usually like the helium tanks and all the pumps and peripherals that you need. There's a system control, which I guess controls the cryo system, measures the temperatures and measures that everything is like going the way it's supposed to. And here you see the processor with the quantum processor, so the chip in the center, the I/O lines, and then the sample holder, which goes to these very low temperatures in the system, like millikelvin, so less than 1/10 of a degree above absolute zero. Here we see higher quality solutions, faster time to solution, and scalable problem solving. And yeah, there's again like some more detailed information on these different components. Then, okay, there's like a learning solution here. So fast track your quantum journey with quantum computing training without a PhD, as we learned. What to expect, accelerated learning and time to value, quantum programming core training, skill up for the future today. So I guess here you can actually sign up for a proper training and then save your spot in a quantum quick start bundle core training plus unlimited Leap Quantum cloud access. And then there's foundations for quantum programming, another starting point in your quantum journey. Here you can register for foundations class. I have also quickly taken a look into that before the video, and I have to say it's like a very nice start. It starts with the very, let's say, essential and basics of everything. And then I guess I only looked at the start, but I guess it will move towards more complex stuff like down the line, all the way to like how to implement stuff on their systems. So go check it out. And finally, there's something about the Ocean toolkit here, which we learned is like on their GitHub repository. It's open source and very openly accessible. So there's like a quantum software architecture and ecosystem. Welcome to Quantum Pioneer. Okay, and then we here see, I guess, the software stack. So we see that there's like different layers here. You see the simulated annealing, the D-Wave API, hybrid sampler at the lowest level. Then you see above that a problem suitable for QPU binary quadratic model, BQM. On top of that, the graph mapping, constraint compilation, and the new mapping methods which are possible. And then here you see like the different applications, I guess, like portfolio optimization, circuit fault detection, scheduling, traffic flow, social network analysis, web advertising, and so on. Let's quickly take a look at the solutions. So here we see the quantum optimization. Quantum computing has emerged as a more efficient way to tackle intricate problems without the need of specialized skills or heavy instruments and new hardware. With cloud-based access to quantum resources, businesses can harness this technology to enhance operating efficiencies. Quantum optimization excels in solving complex combinatorial challenges, making it ideal for industries that have frequently deal with scenarios where small changes have widespread impact. Its applications are expanding from improving delivery logistics and workforce management to optimizing telecommunication networks and cargo operations, all contributing to increased profitability, productivity, and sustainability. And there's more about that here in this business report. Okay, and then here I guess we see again like workforce scheduling, product scheduling, logistics routing, resource optimization, cargo loading. Additional use cases are available. And then again, 99.9% uptime and availability on their cloud solution. Besides that, there are use cases or deep dives into these different use cases. Then you also see something here about the sectors. So you have the manufacturing and logistics sector, public sector, quantum research sector, and quantum AI sector. Let's hop into the quantum AI sector. This is the probably most trendiest one to look at right now. We see here it says the AI industry has made impressive advancement, but faces a computational challenge due to escalating power needs and costs. Quantum computing's integration with AI and ML cloud offer scalable, energy-efficient solutions to address these issues to potentially offer enhanced AI capabilities. Although at nascent stages, this integration could drive scientific innovation and provide a competitive edge. Quantum computers potentially outperform classical computers by speeding up workflows, enabling advanced generative AI models, and optimizing processes. With ongoing developments, these systems could solve larger complex problems faster, reduce energy consumption, and make AI and ML solutions more efficient. And then, here it explains the toolkit, the developer resources, satisfying the demand for quantum AI applications. So here you see a case with the Jülich Forschungszentrum in Germany, where I also used to work at before. Then we see here Triumph, Canada's Particle Accelerator Center, and Honda Innovation Lab and Tohoku University that work together on Boltzmann machines in this case. Okay, with that, so let's quickly also check what is here. So we see learn, feature applications, quantum computing, there's a resource library, D-Wave's approach, publications, customer success stories, events and webinars and training. Then there's something about build here. You see there's a community forum, a getting started guide, code examples. There's a developer page here and some documentation. And finally, there's also something about the company, about D-Wave themselves, the newsroom, leadership, media resources, career contact. And let's quickly check out about the company page. So Quantum realized D-Wave is a leader in the development and delivery of quantum computing systems, software, and services. We are the world's first commercial supplier of quantum computers and the only company building both annealing and gate model quantum computers. Our mission is to help customers realize the value of quantum today. Our quantum computers, the world's largest, are available on-premise or via cloud, supported by 99.9% availability and uptime. More than 100 organizations trust D-Wave with their toughest computational challenges. With over 2 million problems submitted to our Advantage and Advantage 2 systems to date, our customers apply our technology to address use cases spanning optimization, artificial intelligence, research, and more. Their mission is to deliver powerful, commercial, and trusted quantum computing solutions to solve real-world problems. From its inception, D-Wave has been committed to delivering products and services that rapidly transform industries by performing tangible, real-world value with quantum computers. From manufacturing and logistics to financial services, life sciences, and many other industries, find out how D-Wave can propel your business forward by realizing the power of quantum computing today. And again, there's like customer value explained here, use cases, I think, and so on. And I think that's also something which I pointed out earlier in this live session this year. They have actually switched quite a lot from my point of view now, the storytelling from showing academic benchmarks, explaining how their systems got better and better, towards a customer-centric story, as in, here are the applications that people are looking into, here are what they're making out of it, and here is where they see potential advantages. And I think that's a very interesting move towards like something that is, probably more customer-oriented and hopefully also solving real-world problems. Let's quickly check out the newsroom. So I'm recording this beginning of September. We see here there's also already news from September coming in. So this is very much up to date in this case. I also wanted to see this, what we saw at the very beginning. There was this here. Beyond classical, first to demonstrate quantum supremacy on useful real-world problem. Let's quickly check what is happening here. New landmark, peer-reviewed paper published in Science, Beyond Classical Computation and Quantum Simulation. Unequally validates D-Wave's achievement of the world's first and only demonstration of quantum computational supremacy on a useful problem with relevance for materials discovery. So this is focused on materials discovery. Let's see what it says here. Our scientific breakthrough, published in the esteemed journal Science, confirms that our annealing quantum computer outperformed one of the world's most powerful classical supercomputers in solving a complex magnetic materials simulation problem with relevance for materials discovery. The research shows D-Wave annealing quantum computer performs magnetic materials simulations in minutes that would take nearly 1 million years and more than the world's most annual electricity consumption to solve using classical computers built with GPU clusters. So that's very interesting, and I think that's something that I've possibly even mentioned before, but that definitely I've heard about on the side before. It is very interesting because it basically it is to show that like quantum computers, they use the way that these quantum materials work, so the materials magnetism works, basically governed by the rules of quantum mechanics. And if you have a system, like for example this D-Wave annealer, that use the underlying principles of quantum mechanics, then it can actually leverage much more its computational infrastructure to do this simulation. And it is much more natural to use a quantum system to simulate or maybe even emulate quantum properties rather than, let's say, a binary system that is not really well suited to describe these quantum effects. So definitely interesting. We will see what will come out of all of this research and when this is actually going to kind of shift into R&D labs of material discovery companies, and when we will see like the first materials that will have been designed by this in real life, or let's say synthesized in labs maybe. So that's definitely very interesting to understand. We also see here quantum blockchain applications and so on. So if you are interested in, let's say, understanding where the whole application side of things go, definitely also check out what D-Wave is doing here on their website, because as I said, their storytelling is now shifting very much towards like actual applications and people using their machines and what they are using these machines for. So there's a lot of things to learn about the application side of things from what D-Wave is putting out here. Of course, there are also other companies out there but I think D-Wave is also definitely one of the spots to check out. And with that, I will take a sip of my water and then see you in the next episode. Bye bye.